Yo, Grace, what's the time?
It's time for Maths with Mr. Thomas.
Chapter 6, lesson number 6, the sum of an arithmetic sequence. Now, something you may be wondering, this chapter is called Sequences and Series. What is the difference between a sequence and a series? So before we dive into this lesson, let's have a think about that. We all know a sequence could be such as 2, 4, 6, 8, 10, and so on. So it's just a list of numbers in a definite order. A series is when you have that sequence and what you do is you add the terms. So that is a series. So a series is just the sum of terms in a sequence. What we're going to do just now is we're going to find the sum of an arithmetic sequence. In other words, we are finding the sum of the series. So the sum of the first n terms of an arithmetic sequence is found by using this formula. Sn, the sum of n terms, equals n over 2 multiplied by 2a plus n minus 1 in brackets times d. That is how you find the sum of the first n terms. Let's try some examples. So example 1, find the sum of the first 15 terms of the arithmetic series. It's a series because we are adding the terms here. If we weren't adding the terms, if it was just a sequence, we'd have 3, 8, 13, 18, but because we're adding the terms, it is known as a series. First of all, for any of these questions, the way we did in the last lesson, just write down what you know. So if you know the first term, write down a equals whatever it is. If you know the common difference, write down d equals whatever it is. And if you know the nth term, write down what n is. So in this one here, a equals, what's a? Good, a is just 3, the first term is 3. D is the common difference, because we're going up in fives, then d is equal to 5. And n equals, what's n going to be? Brilliant. The question says find the sum of the first 15 terms. So you know n is going to be 15. To find the sum of the first 15 terms, we use this formula up here. So that formula is just there. If we want the sum of the first 15 terms, we're going to have S15 equals. And what we do is we rewrite this, but we replace n with 15. We replace a with 3, and we replace d with 5. So we'd have 15 divided by 2, and then in curly brackets, I've got curly brackets because I've got more normal brackets here, it's going to be 2 times a, so 2 times 3, plus n, take away 1, so that's 15, take away 1, which is 14, multiplied by d, and d is 5, and we end the curly brackets. 15 divided by 2 is 7.5. If we work out this in the brackets, it works out to be 76. 76 multiplied by 75 gives us 570, meaning the sum of the first 15 terms is 570. Yeah! Example 2. Find the sum of the arithmetic series 12 plus 19 plus 26 plus 33 plus and so on, all the way up to 285. Once again, for any of these arithmetic questions, just write down what you know. If you know the first term or the common difference or the nth term. So we know the value of a is 12, that is the first term. We know the common difference is 7, and n equals, well, we don't know how many terms are in the sequence, so we can't write down what n is. But in order to find the sum, well, we're going to use this formula, and we'd have to know what n is. So the first thing we have to do is we have to determine how many terms are in this series. So what we're going to do is we're going to use the formula from the last lesson. We're going to use un equals a plus n minus 1d. Because we know the last term is 285, so we can replace un with 285. We can replace a with 12 because we know a is 12, and we can replace d with 7 because we know that as well. N is what we want to know, and the only unknown here and now is n. So what we can do is we can rearrange that. If we subtract 12 from both sides, that will give us 273 equals n take away 1 times 7. Just write that back to front. If we divide both sides by 7, then n take away 1 is equal to 39. And if we add 1 to both sides, then n equals 40. Which means then that there are 40 terms in this series. What we can do now then, because we know a, we know d, we know n, we can use this formula to find the sum. So we're writing down the sum of n terms equals n over 2, curly brackets, 2a plus n minus 1d, close the curly brackets. That will give us then the sum of the first 40 terms equals 40 divided by 2 multiplied by 2 times a, which is 12, plus n take away 1, which is 39 times d, and d is 7. Simplify that. Well, 40 divided by 2 is 20. Work out this bit in these funky curly brackets. That's 297. Multiply them and you get 5,940, meaning the sum of the series is 5,940. Woo! Example 3. Let un denote the nth term of the arithmetic sequence 2, 10, 18, 26, and let Sn equal the sum of uk going from k equals 1 all the way up to n. In other words, Sn is going to be equal to u, and we're starting off replacing k with 1, so it'll be u1 plus, because this is sigma, it's the sum of, so it'll be u1 plus u, and then replace this with 2, and then replace it with 3, so it'll be u1 plus u2 plus u3 plus u4 all the way up to un. So for part A, find the formula for Sn in terms of n. B, find the least value of n for which Sn is bigger than 1000. And C, evaluate the sum of uk going from k equals 20 all the way up to 40. So the first thing we want to do again is write down what we know. If we know the first term, the common difference, and D. We know the first term is 2, so we can write down A as 2. The common difference, well, we're adding on 8 every time, so we know D is equal to 8. And n, do we know what n is? Well, no, we don't, so we can just leave that. We want to find a formula though for Sn in terms of n, so we're expecting to have n just on the right hand side of this formula. We're not expected to replace it with a number. So what we can do first is we can say that Sn, well, Sn is just going to be u1 plus u2 plus u3. It's just the terms added together. And we know to find the sum of an arithmetic sequence or a series, we can say that it's going to be n over 2 bracket 2a plus n minus 1d. So that is what we would have. So we can say that Sn equals, leave n just as it is, but replace a with 2 and d with 8. So we would have n over 2 times 2 plus n minus 1 times 8. If you simplify that, well, that's going to give us, leave n over 2 just as it is, and we'd have 4 plus 8n take away 8, meaning we'd have n over 2 times by 8n take away 4. From that, well, we can say that 2 is a common factor here, and if we take out 2 as a common factor, then we could have a 2 at the top, so we'd have 2n over 2 bracket 4n take away 2, and we could then cancel the 2 from the top and the bottom, giving us Sn equals n bracket 4n take away 2. So remember, we just take out 2 as a common factor here, it would leave us with 4n take away 2, and we cancel the 2 from the top and the bottom. Multiplying out the brackets, that will give us that the sum of the first n terms equals 4n squared take away 2n. And that is the answer for part A. Part B, find the least value of n for which Sn equals or is bigger than 1000. To do that, well, the last answer was Sn equals 4n squared take away 2n. That is the sum of the first n terms. We want to find the value of n for which that is bigger than 1000. So the first thing to do would be to set it equal to 1000. So say Sn equals 1000, well, if it does, we know that 4n squared minus 2n would equal 1000. If we subtract 1000 from both sides, then 4n squared take away 2n take away 1000 would equal 0. And to solve that, we would have to factorise. So the first thing we could do is we could take out 2 as a common factor, or we could just divide everything by 2. Dividing everything by 2 will give us 2n squared take away n take away 500 equals 0. Factorising that, what does it give you? Perfect, you cannot factorise. And if you can't factorise it and you still want to solve it, you would have to use the quadratic formula. So quadratic formula with a equals 2, b equals negative 1, and c equals negative 500. Quadratic formula then, n equals negative b plus or minus the square root of b squared minus 4ac over 2a. That will give us negative 1, which is going to be plus 1, plus or minus the square root of negative 1 all squared, take away 4 times 2 times negative 500 over 2 times 2. Simplify that and it gives us 1 plus or minus the square root of, underneath the brackets here you get 4001, and we're dividing that by 4. Work that out on the calculator, do one of them with a plus, one of them with a minus, and it gives you 16.06 and so on, or negative 15.56 ... We know that n is a term in the sequence, so which term is it? Well, it's going to be the first term or the second or the third or the fourth. It is not going to be a negative number. N has to be bigger than 0, so we can dismiss this negative 15.56. So since n is a whole number, we know then it's going to be this 16.06, and it's the 16.06th term that will give us 1000. That doesn't make any sense, though it has to be a whole number, and if we pick 16, if we round down, well, that'll be less than 1000, so we'd have to round up. So it would be the 17th term that would be the first one that would give us a sum that would exceed 1000. So therefore, n equals 17. Part C, evaluate the sum of UK going from k equals 20 all the way up to 40. So the first thing to think about is, what does this actually mean? Well, what it means is we're replacing k with 20, so we'd have U20. Then we would replace k with 21, so we'd have U21, and we would add them together. Then we'd replace it with 22, and so on, and we'd keep on going until we got to U40. How do we get that though? Well, really, the way we're expected to do it is to think about the terms going from the first to the second to the third to the fourth, all the way up to the last one. Normally we'd have k equals 1 up to 40. So we'd have u1 plus u2 all the way up to 40. But what we don't want is the terms from 1 all the way up to 19. We want to start with the 20th. So what we do is we would then subtract u1 plus u2 all the way up to u19. So in other words, we'd have the sum of the first 40 terms take away the sum of the first 19 terms. How could you work this out? Well, remember for part B, the answer was Sn equals 4n squared take away 2n. So all we've got to do is we've got to use that formula to work out S40 take away S19. The sum of the first 40 terms therefore will be 4 times 40 squared. Take away 2 times 40, which will equal 6,320. S19 is going to be equal to, well, if we replace n with 19, it will be 4 times 19 squared. Take away 2 times 19, which equals 1,406. Therefore, if we want to work out the sum of UK going from k equals 20 up to 40, well, really that's just S40 minus S19, so it's going to be 6,320 take away 1,406, which gives us 4,914 as our answer. Woo! Example 4, the terms of a sequence are given by UK equals 11 take away 2k, with k bigger than or equal to 1. Part A, obtain a formula for Sn where Sn equals the sum of UK going from k equals 1 all the way up to n. In other words, it's u1 plus u2 plus u3 all the way up to un. And part B, find the values of n for which Sn equals 21. So the first thing we want to do to find a formula for Sn, so u1 plus u2 plus u3, well, the first thing we need is a sequence. So to get that sequence, what do we do? Well, first of all, we need to work out the first few terms of the sequence. So to get that, well, we know that the terms of a sequence are given by UK equals 11 take away 2k. So let's say that k was equal to 1. So if k equals 1, then we'd have u1, and that would be 11 take away 2 times 1, which equals 9. So we know the first term of the sequence is 9. If we want to work out the second term, well, that would be u2. And u2 would be equal to 11 take away 2 times 2, which equals 7. If we wanted to work out u3, it would be 11 take away 2 times 3, which is equal to 5. and so on. We could work out the fourth one, and so on. So really, because you can see here that you're going down by 2 every single time, it is an arithmetic sequence, which is what we are expecting. We're subtracting 2 every time, so we can say then that this is an arithmetic sequence with the first term of 9, so a equals 9, and a common difference, because you're going down by 2, the d would equal -2. To obtain a formula for Sn, the sum of the first n terms, well, that is going to be given by this formula here. So n over 2 brackets 2a plus n minus 1d, and we know then that a is 9, d is -2, and n, well, we don't know how many terms we have. We want to find a formula leaving n just as it is, so we're going to have n over 2 brackets 2 times a, replace a with 9, plus n take away 1 times d, and d is -2. Simplify that, and you end up getting down to 10n take away n squared. All you're doing from that line to this line is you're taking out 2 as a common factor. So you've got 2n over 2 brackets, and if you take out 2, you'd be left with 10 take away n. Cancel the 2 from the top and the bottom, then multiply the brackets out, and you get 10n minus n squared. So that is a formula for Sn. Part B, find the values of n for which Sn equals 21. Well, it's going to be equal to 21 when the 10n take away n squared equals 21, because that formula there is a formula for the first n terms. So 21 equals 10n take away n squared. If you add n squared to both sides, subtract 10n from both sides, then you get n squared take away 10n plus 21 equals 0. To solve that, you can factorise it. Anybody? Factorise it for me. Brilliant. N take away 7 bracket n take away 3, meaning then that n equals both 7 and 3. So the question said find the values of n for which Sn equals 21. Well, n, the sum of the first 3 terms will be 21, and the sum of the first 7 terms will also be 21. Because if you think about those terms, you were going into the negatives. You had 9, then 7, then 5, then 3, then 1, then you'd have -1, and then -3, and so on. So that is why you would have 2 answers. Example 5, the sum Sn of the first n terms of a sequence u1, u2, u3, and so on is given by Sn equals 8n minus n squared, where n is bigger than or equal to 1. Part A, calculate the values of u1, u2, and u3 and state what type of sequence this is. And part B, obtain a simple formula for un in terms of n. So to do this, the first thing we need once again is to work out the first few terms of this sequence. We are given a formula for the sum of the first n terms, so let's say we just had one term. Let's find out what the sum of that one term will be. That will let us find out what that first term actually is. So let's say we want to work out S1. So that is the formula we have. S1 will equal, well, that's going to be 8 times 1. Take away 1 squared. Work that out and you get 7. So the sum of just one term is 7, meaning then that u1 equals 7. If we have 2 terms, then the sum of the first 2 terms will be equal to, we'd replace n with 2. So it'll be 8 times 2. Take away 2 squared, which equals 12. So we know the sum of the first 2 terms is 12, but we know the first term is 7. So what must the second term be? Brilliant. All you want to do is do S2 take away S1, so the sum of the first 2 terms take away the sum of the first term. In other words, you'd have 12 take away 7, which equals 5. And you can check that because 7 add 5 equals 12. So that would be the sum of those 2 terms. Let's do a few more. Let's get a third. So the sum of the first 3 terms will be equal to, well, that will be 8 times 3 take away 3 squared. And that works out to be 15. So we know the sum of the first 3 terms is 15. How do we work out what this third term is though? Well, we know the sum of 2 terms was 12. So what would we add on to that to get a sum of 15? Well, we'd have to add on 3. So u3 would be equal to the sum of the first 3 terms, take away the sum of the first 2, which is 15, take away 12, which equals 3. Therefore, you could keep on going, but we know our sequence is 7, 5, 3, and so on. Because we are going down by the same thing every time. What type of sequence is it? Arithmetic! Perfect! It is an arithmetic sequence. And you can see the first term is 7, so it's an arithmetic sequence with first term a equals 7. And there's a common difference. Remember, it's going down, it's decreasing. So we'll have negative, and it's going down by 2. So it'll be negative 2. Woo! Part B, obtain a simple formula for un in terms of n. We already know that our sequence is 7, then 5, then 3, and so on. It's an arithmetic sequence with a equals 7, common difference of d equals negative 2. Because we know a is 7, because we know it's got a common difference of negative 2, and because we know where we are wanting our simple formula in terms of n, we're not going to replace n with a number, we're just leaving it as n. And in the last lesson we learned that we can give a general term, un equals a plus n minus 1 times d, replace a with 7, replace d with negative 2, and that gives us 7 plus n minus 1 times negative 2. Multiply the bracket, should have negative 2n plus 2, meaning then our answer will be 7 add 2 is 9, and we still get this negative 2n. So un, a formula for un, is just 9 minus 2n, and that is your answer. Try some of these questions looking at the sum of an arithmetic sequence using this formula here. There are questions on page 22 and 23 of the Unit 2 booklet. If you need it, email me it. Best of luck. Have fun. Bye. Woo! Yeah.